So today I have a SUSChem review for you guys. This includes 7 questions, and I tried to be as comprehensive as possible, but my apologies if I missed anything. So step 1 of the new ibuprofen synthesis is shown below. What is the percent atom economy for the product? So a lot of this is just plugging into the formula. So we have the atom economy formula right here. And the indicates molar mass, and C will be the desired product. And then on our denominator, we have all of the molar masses of the reactants. So in this case, our desired product is C12H16O, and the molar mass is 176.26. And then on the denominator, we have the 2 reactants. And then multiply by 100 because we want this to be a percentage. And if you calculate this, you'll get 74.6%. Next, using the same reaction, 15 grams of C10H14 and 12.5 grams of C4H6O3 are combined. What is the theoretical yield of the product? So I like to start by just writing out the formula. And remember, with theoretical yield, that is what will theoretically happen if all of the reactants are used up perfectly and there's no error, but that differs from the actual yield, which is what we actually get when we experiment it in real life with the different confounding variables. So it says 15 grams. I just like to write it underneath the formula. And in order to figure out the theoretical yield, we need to figure out what the limiting reagent is. So to do that, we're going to find how many moles of each reactant we have. So I have the mass and the molar mass, so that allows me to find the moles, which will be 0.11, and this will be 0.122 moles. So because this one is smaller, this is the limiting reagent, and we're going to use this to find the theoretical yield of the product. So this has a molar mass of 176.26 grams per mole, and now we can figure out what the mass is, and that will be 19.4 grams, and that's the theoretical yield. So we're given the actual yield now. This is still the same reaction, and the atom economy is also given to us. What is the reaction mass efficiency for this step? So the reaction mass efficiency is atom economy times yield. So first, let's find what the yield is. So we calculated our theoretical mass. So yield is actual over theoretical. So actual is 14.2 and theoretical is what we just calculated up here, which is 19.4. So our yield will be 0.73. And now we can plug this into the formula. So reaction mass efficiency is 0.746, make sure it's in a decimal, times 0.73, and we'll get 0.546. In a different synthesis step, 8.50 grams of reactant A and 6.20 grams of reactant B are reacted with 150 grams of solvent. An additional 200 grams are used to purify the product, and our actual yield is 7.3 grams. What is the E factor? So E factor is basically just all of the masses of everything you need to make the product, so including the reactants, the solvents, the catalysts, minus the mass of the product divided by the product. So we have two reactants, and we're given the mass. And for solvents, we have 150 grams of solvent, and we have an additional 200 grams that are also used to purify the product. And now we just subtract by the mass of the product, which is 7.3. And you'll get 48.96. That's it. Okay, so in step 3 of the new ibuprofen synthesis, C12H16O reacts with H2 gas over a nickel catalyst to produce the product. What volume of H2 gas at 1 bar and 25 degrees Celsius is needed to fully react with 8.80 grams? So whenever you see a pressure that's given to you and also a volume, it probably means you're going to use this formula, PV equals nRT. So once again, I like to write out the formula a little bit bigger. And we have 8.80 grams of this. And we're trying to figure out what volume. So we're looking for the volume. We know the pressure, we know the temperature, and we know the R value. So what we need to find in order to calculate for volume is N, which is the number of moles of H2. So how do we do that? Well, it says fully react with C12H16O. So that means whatever moles of this, it needs to be the same amount of moles as the H2. So if we know the mass and we know the molar mass, we can calculate the moles, which is 0.05. And because they fully react with each other, that is the amount of moles of H2. And now we can plug it into the formula. So I'll rearrange for volume. And just plug our values in. Remember that temperature needs to be in Kelvin, so whatever value I have in degrees Celsius, I'm adding 273 to it. And pressure is 1 bar. So calculate and you'll get 1.237 liters. Okay, next, a company improves its drug synthesis by doing all of these things, and we have to figure out which green chemistry principle is not directly demonstrated. So I'm going to go over each phrase and we'll figure out which one is demonstrated, and then at the end we'll be left with the one that isn't directly demonstrated. So replacing the aluminum chloride with a recyclable Ni catalyst. This looks like catalysis because it's a catalyst. So we know that's not option A. Next, running the reaction at 50 degrees Celsius instead of 200 degrees Celsius. This will be energy efficiency because we can do it at a lower temperature. Reducing the number of synthetic steps from 6 to 3, cutting the number of byproducts. This is waste prevention. And then, which one is not directly demonstrated? It's use of renewable feedstocks. Okay, our last question. We're given two processes, X and Y, and it tells us the atom economy and overall yield. And we need to figure out which statement is correct. So let's go through all of these statements first. So it looks like these statements are asking us to compare the RME. So let's go ahead and calculate that for both processes. Remember that it's atom economy times yield, so I can do 0.46 times 0.26, 0.12, and then for Y, it's 0.77 times 0.51, which is 0.39. So the reaction mass efficiency of Y is greater than X. So now let's go through all of our options. This one is not correct. This is not correct. And this one is also not correct. So it has to be A. And is process Y greener? Yes, a higher RME means that the process is greener, because if you look at the formula, you have a higher yield, which is much better because more of the reactants are turning into product. And atom economy, remember that atom economy is the molar mass of the product over the molar mass of the reactants. So if you have a higher atom economy, that means you have a higher molar mass of product, so you're making more product. So it's greener. So process Y will be greener than X.